Hi, in this video, we're going to see how to find the vertex of a quadratic function. Okay, first let us see how to find vertex of a quadratic function if the function is given in general form, that is y equals to ax square positive bx positive c. So this is a general form of a quadratic function. Okay, if a quadratic function is given in general form, there is a formula to find the exponent of the vertex. That is, x is equal to negative b over 2a. So using this formula, we'll be able to find the exponent of the vertex. Once we get the value of the exponent, we can plug in that value for x into the given quadratic function, and we can find the value of the y coordinate of the vertex. Okay, let us see how it works with an example. Okay, consider a quadratic function, for example, x square positive 6x positive 7. Okay, so here the quadratic function y is equal to x square positive 6x positive 7 is in general form. So when I compare the given quadratic function with y is equal to ax square positive bx positive c, so what value should I get for a? So for that, I have to look at the coefficient of x square in the given quadratic function. So I don't have any number in front of x square over here. So we have to assume there is 1. Whenever there is no number in front of a variable, so I have to assume it's 1. So the coefficient of x square is 1. That is, the value of a is 1. And the value of b is 6. And we don't have to get the value of c because in the formula to get the exponent of the vertex, we don't have c. So the formula is x is equal to negative b over 2a. So we need the value of b and the value of a. Okay, now let's take the formula to find the exponent of the vertex. That is, x is equal to negative b over 2a. So x is equal to negative, the value of b is 6, and 2 times the value of a is 1. So negative 6 over 2 times 1 is 2. So 2 goes into 1 times 2 goes into 6 thrice. I get negative 3. So the x coordinate of the vertex is negative 3. So to get the y coordinate, I have to plug in x is equal to negative 3 into the given quadratic function. So now let's plug in x is equal to negative 3 into the given quadratic function. So that is y is equal to negative 3 the whole square, positive 6 times negative 3, positive 7. So I plugged in negative 3 for x into the given quadratic function. So now I have to evaluate the value of y. So y equals to negative 3 whole square is just 9. And positive times negative will become negative. 6 times 3 is 18, positive 7. So y equals to, when I combine 9 and 7, it will be positive 16. When I combine positive 16 and negative 18, it will be negative 2. So the y coordinate of the vertex is negative 2. Already we got the x coordinate of the vertex, that is negative 3. So finally, the vertex of the given quadratic function is negative 3 comma negative 2. Okay, let's look at another example. Here we have a quadratic function. So here in this quadratic function, there is no x term. So if I want to get this quadratic function in general form, that is y is equal to ax square positive bx positive c, I must have x term, but the given quadratic function does not contain x term. So what I'm going to do is, I'm going to write 0x in this function, because if I want to get the given quadratic function in the general form, that is y equals to ax square positive bx positive c, it must contain x term, but originally it does not contain x term. So that's why I'm adding 0x. Okay, now when I compare the given quadratic function with y is equal to ax square positive bx positive c, I get a is equal to negative 7 and b equals to 0. Already we know the formula to find the x coordinate of the vertex, that is x is equal to negative b over 2a. So negative, the value of b is 0, and 2 times the value of a is negative 7. Okay, here when I divide 0 by any value, it will still be 0. So the exponent of the vertex for the given quadratic function is 0. Okay, now to get the y coordinate of the vertex, I just have to plug in the value of the x coordinate, that is 0, into the given quadratic function. So that is, I'm going to plug in x is equal to 0 into the given quadratic function. Then I'll be getting negative 7 times 0 square positive 12. So I get y is equal to, the value of 0 square is 0, 0 times anything, 0 positive 12. I get y is equal to 12. So the vertex is 0, comma 12. How to find the vertex of a quadratic function? If the function is given in vertex form as standard form, that is y is equal to a times x negative h the whole square positive k. So this is a vertex form or standard form of a quadratic function. So when a quadratic function is given in vertex form or standard form, it's pretty simple to get the vertex. So to get the x-coordinate of the vertex, you have to consider the value at the position of h, and the y-coordinate of the vertex, the value we have at the position of k. So the vertex of this quadratic function in vertex form is h comma k. Okay, let's look at some examples based on this one. Okay, consider the quadratic function, that is y is equal to 2 times x negative 3 the whole square positive 5. Okay, let's compare. Actually, this is a given quadratic function is in vertex form. So we can compare the given quadratic function with y is equal to a times x negative h the whole square positive k. Already we know that the vertex is h comma k. So here in the given quadratic function, so what value do you have at the position of h? That's 3. What value do we have at the position of k? That's 5. So the vertex of the given quadratic function is just 3 comma 5. Let's look at another example. Here we have a quadratic function that is y is equal to 5 times x positive 3 the whole square negative 7. This is almost in vertex form. Let's compare the given quadratic function with so y is equal to a times x negative h the whole square positive k. Okay, when I compare the given quadratic function with this one, so here I have negative, here I have positive, here I have positive, here I have negative. Okay, so if I want to get the vertex, I need the values of h and k. If I want to get the values of h and k, I have to compare the given quadratic function with this stuff. So for that, I need the given quadratic function to be exactly in this form. That is, here instead of positive, I need negative. And here instead of negative, I need positive sign. So here our aim is to change the signs. So the first positive sign, this positive sign should be changed to negative, and this negative sign should be changed to positive. Okay, let's see how it is. Okay, here y equals to 5 times x. Instead of positive, I need negative. So I put negative sign over here. So I'm taking negative sign for this 3. It is x negative of negative 3 the whole square. So here you may have a question. So why should I take this 3 as negative 3? So because instead of positive, I've taken negative. So to compensate that, I've taken this 3 as negative 3. Because even when I simplify this one, it has to be equal to the original stuff. So look at here, negative times negative will become positive. We have x positive 3 the whole square, exactly what we have in the given quadratic function. And also here, instead of this negative, I need positive. So I put positive. So to compensate this, I'm taking this 7 as negative 7. Look at it. When I multiply this positive times negative, it will be negative. So I have 7. So I have made some changes in the given quadratic function, but the new quadratic function, what I get over here, must be equal to the given quadratic function. Please make sure of that. So negative times negative will become positive. So it will become x positive 3 the whole square, and positive times negative will become negative, and we have 7. Okay, now we can compare this quadratic function with y equals to a times x negative h the whole square positive k. Now this is exactly in this form. Okay, so what value do we have at the position of h? That is negative 3. And what value do we have at the position of k? That is negative 7. So the vertex h comma k equals to negative 3 comma negative 7. So the vertex of the given quadratic function is negative 3 comma negative 7. Let's look at another example. Here we have a quadratic function, that is y is equal to 2x negative 5 the whole square positive 4. It's almost in vertex form. Okay, let's compare this the given quadratic function with the vertex form. Y is equal to a times x negative h whole square positive k. Okay, here in the vertex form, the coefficient of x inside the parenthesis here is just 1. But in our quadratic function, the coefficient of x is 2. So the coefficient of in vertex form inside the parenthesis, always the coefficient of x has to be 1. But in our function, it's 2. So we should try to get rid of this coefficient 2. So we have to make the coefficient of x inside the parenthesis as 1. Okay, let's see what has to be done. Okay, so to make this coefficient of x as 1, what I'm going to do is I'm going to factor 2 from these two terms. So when I factor 2 from these two terms, so what stuff will I get inside the parenthesis? So to know the stuff inside the parenthesis over here, I have to divide these two terms, 2x and negative 5, by the 1 I factored out. Okay, so when I divide the first term 2x by 2, the 2 will cancel out, I just get x. When I divide the second term negative 5 by 2, I'm getting negative 2.5 whole square positive 4. So here, two quantities. The first quantity is 2 and the second quantity is x negative 2.5. Both of them are multiplied and we have the common exponent 2. So according to the exponent rules, whenever two quantities are multiplied and we have the common exponent, the exponent can be distributed to each quantity. So then I'll be getting 2 square times x negative 2.5 the whole square positive 4. So the value of 2 square is just 4 times x negative 2.5 the whole square positive 4. So here look at the coefficient of x inside the parenthesis. That's just 1. Okay, now I think it's exactly in the vertex form. That is y is equal to a times x negative h whole square positive k. Okay, so the vertex h comma k equals to. So what value do we have at the position of h? That's 2.5. What value do we have at the position of k? That's 4. So the vertex of the given quadratic function is 2.5 comma 4.